Okay, Q patterns. Um, this one's similar to the difference of squares. So keep in mind, a little while back we did things like this: x squared minus 16, and that's x minus 4 and x plus 4. Okay, so we also have to memorize a couple of Q patterns. And let me first show you where they come from. So let's start with x plus 2 times x squared minus 2x plus 4. If I asked you to distribute this, you would do x times x squared, that's x cubed. Then it would be minus 2x squared, and then the last one will give you a plus 4x. I'll do the same thing with the 2, so that's 2x squared, but now positive. Then we get minus 4x, and 2 times 4 is 8, positive. And then you can probably see that when you add these, that's x cubed, these cancel, and that one as well, so x cubed plus 8. So x cubed plus 8 is factorable. It should be factorable into that expression. Similar thing happens if this is an x minus 2, and then that will be a plus 2 over here. So notice that if this is a plus and that's a negative, then it also should work when that's a negative and that's a plus. And you can probably sort of guess what happens here, but if I work the whole thing out, so that's the first x distributed, and then the cancellations with the negative here, and the negative there, and then the negative times the positive 4 makes it a negative 8. Still wrote down a negative, or a plus. And now when you cancel everything, you end up with x cubed minus 8. So x cubed minus 8 is called the difference of cubes. So that's a sum of cubes, and that's a difference of cubes. Sum, and then here, a difference. So those are two patterns that we have to sort of add to our toolbox. So a sum of cubes factors, if this is a plus, then you get a plus here and a minus there. Okay. Other than that, it's the same on both sides. So if this is a negative, you get your negative here and your plus there. But look at this thing. That's an x squared. That's the same. That's an x and a y. That's an x and a y. And that's a y squared. And the same thing over there. So how does that work in practice? Well, the first thing is that you have to recognize this as a cube. Well, that's an easy one there. And 27, most of us do know that 27 is 3 cubed. So one of the things that you get better at is recognizing what's a cube or not. So that's a plus, right? So I need the sum of cubes. So this one starts with an x plus 3. And then here I get an x squared. And then the x and the y just literally means do x times y. So x times 3 or 3 times x. So that's 3x. And then that last one's a y squared. So y squared, 3 squared is 9. Now let's check my sign. If this is a plus, then that's a negative. And then this is always a plus. So how does it work here? So again, that's an x cubed minus a 3 cubed. Well, not again. Now it's a negative. So if that's a negative, then I need to start with a negative here. I still get the x squared. I still get the 3x in the middle. And 3 times 3 is still 9. But if that's a negative, then this needs to be a plus. And the back is always a plus. So it's just a matter of can you recognize what's being cubed. So y cubed, that's easy. And 125, 5 cubed would be 125. So that's a 5a that's cubed. So starting with a plus, then you need a y plus 5a over here. And this is a square, then this is the two things multiplied, so 5ay. And then 5a squared, so be careful with that, because you do need to do 5 squared is 25, and then the a squared as well. So when I do this sort of fast sometimes, I sometimes forget to square the number here. So that's a plus, that's a negative, this is a plus. So be careful with that. And you see the same thing here. So 27m cubed, so 27m cubed, so that's a, 27 is 3, right? So that's a 3m that's being cubed, minus 1,000 is a 10 cubed, so 10k cubed. So just make your pattern. 3m minus 10k, those are the two things that we're working with. And then this one should be 3m squared, so that's 3m squared, that's actually 9m squared. And then the middle is these together, so 3 times 10 is 30, and then an m and a k. And then the last one, that's the 10k that's squared, so that's 100k squared. And now let's check my sign. This one is a negative, that one is a plus, and the last one's always a plus. Okay. And we can make these a little more annoying or more difficult. So initially we might think, well, 16 be a cube. Well, 16 isn't a cube, so this only works if it's a cube. But 16 and 432 both have a 2 in it, so don't forget to take out your common factors. So when you do that, you might be more likely to see that that is a cube. So 8 is 2 cubed, and 432 divided by 2, I guess I should be able to do that. That's 216. Okay, so now I have to find a number that when I cube it, I get 216. Well, we just did, sorry, I think I just had a problem. We just did 5 cubed, and 5 cubed was 125. So if it's anything, then it's got to be more than 5. So, let's try what happens with 6. So what is 6 times 6 times 6? And I think 6 cubed should work here. So let me double check that. 6 cubed is 216. So yes. Okay. So this is actually a 2b that's being cubed, and this is a 6 that's being cubed. So that means I get the following. I get 2b plus 6, and then 2b squared is 4b squared plus 6 times 2 is 12, 12b plus 6 squared is 36. Okay, don't forget the 2 that you already took out, so that 2 is important. So now it's completely factored, so that's a little longer. Okay, this also works if you have an expression that's being cubed. So 27 is 3 cubed, so we saw that a lot now. So this should be, let's just write that as a 3 cubed. So this is, let's see, it's a 3 minus x plus y. And then we get 3 squared, which is 9, minus, I don't know if that's a minus. That's going to be a plus, isn't it? So it's 3 times xy, so 3xy. Plus, then x plus y squared is the last term. Okay, so that's a little ugly. We might be able to clean it up a little bit. So it's minus, distribute across, so that's 3 minus x minus y. Then we get 9 plus, this is 3x plus 3y. Yeah, I mean, it's just getting long, but I do think we might have to do this. And then x plus y squared, that's an x squared plus 1x and 1y, so 2xy plus a y squared. And I was actually expecting to maybe get some like terms in here, but it doesn't look like I do. Let me double check. So 9, no other numbers, that's an x, that's just a y, that's an x times a y, and those are squared. So that's it. Now I really don't want to check that by foiling, so this is one of these things where I sort of, hopefully you have some faith in what you do and you feel comfortable with it. So, thank you.